Hello everyone, my name is Lucas Hoffman. I'm a second year PhD student at CEOA, working on the coupling between heat and electricity. And within my research topic, we came up with a methodological question that I'd like to present you today, which is, should the heat production be diluted or non-diluted? I will present you what I'm talking about just now. So to do so, we will build together a simplified energy system model at the national territory scale. We start with electricity production with some production units and a demand. We add the district heating network with heating production units and thermal storage. And then we add individual heating devices such as heat pumps and boiler and so on. And we need a heat demand, right? But if we do so, if we put only one single heat demand, it means that district heating network and individual heating can provide heat whenever they want. That's what we call dilution. But in fact, currently, individual and district heating mixes are non-diluted. Dwellings connected to district heating don't rely on their neighbors' heat pumps as well. Yet, energy models do not systematically take this into account. Maybe it's because allowing the dilution offers a wider scope of possibilities from an optimization point of view. Maybe it's more interesting to have this dilution, but it prevents an accurate cost calculation of the thermal system. So for us, at least, it was very confusing, and we wanted to know what should we do. Before answering this question, we wanted to assess if the non-dilution affects the result at all. To do so, we created a heat and electricity toy cost optimization model, the one I just showed you a couple slides before, which was written in MILP. And then we ran the model over 1 year at an hourly resolution, and we observed the difference with and without this non-dilution constraint. Here are the two main observations. The first one is that when applying this non-dilution constraint, district heating becomes less competitive. In fact, sometimes it's not installed at all by the optimization because it loses its short-term flexibility to address any heat demand. This is easy to understand because the district heating, when diluted, can provide heat to every consumer, but when non-diluted, it can only provide heat to the consumers connected to district heating network. This can be seen thanks to this graphic. It is the injected heat from the district heating. In the diluted case, we see this high frequency injection rate. It can provide heat whenever it wants. But in the non-diluted case, we see this more familiar patterns because in this case, the district heating can provide heat only to the consumer connected to the district heating. So the ratio is fixed for every time step. The second observation is that the thermal energy storage is greatly impacted when the non-dilution constraint is applied. This can be seen thanks to the state of charge of the thermal storage. In the non-diluted case, we see less charge and discharge cycle, and we see that more energy is stored on longer period. So to conclude, to dilute or not to dilute, from our point of view, to not dilute, because diluting individual and centralized mixes gives wrong district heating competitiveness and a wrong thermal storage behavior. And now we are applying the same methodology, but this time between the individual heating devices themselves. Thank you very much.